So now for something completely different, drones. So we're going to have a kind of this is a late breaking news kind of panel. I think the report from this group just came out yesterday. So I'm sure you've all had a chance to read it cover to cover. And we're going to have a chance here to have some of the people who actually were on the committee that put this report together that was delivered to the FAA. I want to introduce the person who's going to moderate this panel and who also chaired this committee, who did a fabulous job along with our help from Dwayne Day, who I think I saw earlier from the Academy, to help us put pen to paper when all we really wanted to do was sit around and just talk. So it was good. So George is not unknown to most of you. He's had a long and distinguished career with I think over 40 clients and counting, to which he provides amazing advice. We know him at RTCA. I think at one point when I got here, I actually thought he was that he worked for RTCA, just for his passion in what we do. He's been involved in our committee since 1970. He's on the program management committee. He's co-chair of our GNSS SC-159 committee. He serves on and has served on the Next Gen Advisory Committee subcommittee. He also serves and has helped in leadership in Equip 2020. He was a recipient of our RTCA Achievement Award in 2006, and he's been involved in the National Academy of Sciences, Engineering, and Medicine for a number of years when it was inducted there, I think just last year. So it is with great pleasure that I hand this over to the very capable hands of George Fliegler. Thank you.
Thank you, Margaret. Well, good afternoon, all. It's a pleasure for my colleagues and I to be here to discuss our National Academies report of the Committee on Assessing the Risks of Unmanned Aircraft Systems Integration. As Margaret mentioned, this report was issued yesterday, and it's been the subject of a number of press releases, so we would like to, and there are a number of additional briefings that are scheduled. So we'd like to go through it with you. I had a few charts to introduce the subject. So if we could put one of those up, I'd be grateful. It's right here. Okay. Thank you. So that's the introduction. It's a congressionally mandated study out of the most recent Reauthorization Act. The study duration was from September of last year, and seems like forever, but the first time we got together was late September of 2017. And in the best of RTCA traditions, we delivered our report that was due in May to the Federal Aviation Administration. We had a 14-member committee, excellent work sector balance, 6 from academia, 4 from the nonprofit industry, and 4 from the industry sector. And we had 7 key conclusions that are articulated in the summary of the report, and 11 recommendations and several findings. So I'll just give you a sampler if you haven't had an opportunity to look at the report. Use a holistic picture of overall risk and benefit of UAS operations. Not simply look at what can go wrong, though one needs to look at that, but also look at the benefits that the UAS operation in question can provide. Establish and publish within recommended timelines, and we give specific timelines, recommended timelines in the report, a predictable, repeatable, quantitative procedure, risk-based process for certifying UAS operations and systems. And then ensure time-bound reviews with more delegation of risk assessment to the applicant using that clearly defined risk assessment process. For some operations that might have de minimis risk, after establishing what a level of de minimis risk is, after you establish that, perhaps if an operation is of de minimis risk, have the applicant get appropriate insurance and let the risk assessment comprise the insurance underwriting process. Now, the committee is very fortunate to be asked to chair this committee. We have 3 members of the committee with us today, 14 folks. I would like to mention before I introduce the panelists that, as you can see, one of the members of our committee, and a very key member at that, is Margaret Jenny. And our study director, Dr. Dwayne Day, is out there somewhere, because I saw him just before we began the panel discussion. So, in terms of introducing folks, to my immediate left is Dr. Brian Argro, and Brian is Chair of Aerospace Engineering Sciences, Director of the Integrated Remote and In Situ Sensing Program, and Director Emeritus of the Research and Engineering Center for Unmanned Vehicles at the University of Colorado in Boulder. His research topics include small unmanned aircraft system design and airspace integration, high-speed aerodynamics, sonic boom, and engineering education. And the committee at the National Academies was formed under the Aeronautics and Space Engineering Board. Brian's a member of the board, so we had one of the bosses here on the committee. So, next, sitting next to Brian is Dr. Karen Marai, who's an associate professor in the School of Aeronautics and Astronautics at the College of Engineering at Purdue University. And Karen has worked on developing new ways of assessing safety and risk in complex socio-technical systems in general and air transportation systems in particular. This is not her first National Academies committee. She served as a member of the National Academies Committee on Propulsion and Energy Systems to reduce commercial aviation carbon emissions. And then to Karen's left is Paul McDuffie, well known here at RTCA. He has recently got a new name. You know, we've known him for years as Vice President of Government Relations at In Situ, a subsidiary of the Boeing Company. He is now Business Development Executive for Boeing Horizon X. And he's currently serving as co-chair of RTCA Special Committee 228 and a member of the Drone Advisory Committee Subcommittee, and he is a member of the Unmanned Aircraft Safety Team Steering Committee. Paul's an active pilot, and he has logged over 8,000 hours of flight, and that added yet another very useful piece of diversity and diversity of experience to our committee. So with that, I'd like to move into a discussion of several questions that I'd like to pose to the panel. Firstly, how is risk analysis done for unmanned aircraft today? Brian, want to take a stab at that?
Well, I'll talk specifically about the example that what we've done at the University of Colorado for several years now. Much of our applications are focused on things ranging from mobile ad hoc networks to, actually I have a team right now that's in western Kansas about to do supercell intercepts using drones to fly beneath supercell thunderstorms. And what we generally, our applications are generally done under a COA, a Certificate of Authorization, a waiver, and usually what we do is we start with looking at the population density of where we propose to fly. And we do some probabilistic analysis there focused on that. And then we, because we are a public institution, we actually do a self-certification of our aircraft, and we use handbook, military handbook 516B, as a standard, and the parts that are applicable. Obviously, we don't carry stores to drop and things like that, but the things that are applicable. And then we do an analysis basically using the document 8040B or 4B, and we do a risk matrix in which we basically use our expertise to determine what we, based on the application, and we develop our opinion, actually, of the risk and map that onto the risk matrix. And then we look, of course, at mitigations to, if things are in an area where the risk is too high, we look at ways to mitigate that until it's acceptable. And with that, basically, we then propose that to the FAA as part of the application process for the COA. And if things are in order, the COA will be granted. And if not, then we go back to the drawing board on some parts of it that aren't satisfactory. So it is sometimes an iterative process. So that's basically how we do it with the COA approach.
Thank you. Paul?
Yeah, yeah, thanks, George. You know, in my previous life, and again, most of you know me from my in situ days, we were more or less an early entrant into this process of attempting to get not only operational approval for our systems, but actually driving toward the certification of the actual aircraft. We were ultimately successful. As an early entrant, I think it was safe to say we were more or less guinea pigs in the whole concept of risk-based approval, performance-based approval or certification of the platform. Our experience is very similar to Brian's. We were specifically focused on an actual commercial application for the vehicle and beyond line of sight activity. That in itself created a fairly rigorous process where we, along with the FAA, began working in this, as I said earlier, this risk approach, this risk-based approach toward obtaining the operational approval for the flights that we were going to conduct up in the high Arctic off the north slope of Alaska, all the way to the operations that we supported for the BNSF Railroad as part of Pathfinder 3, some of you may recall. Both of those and some other operations that we were involved in primarily brought our people to bear to define what the concept of operations was for those particular missions, identify the risks associated with them, and then bring those risks and suggested mitigations to the FAA. As I said, it was very early in this process. I think we were crawl, walk, run, much like the folks in the agency were. We put ourselves through 2 safety risk management panels on one particular project. Why 2? There was disagreement among the members of the panel as to what was acceptable and what wasn't, which essentially tells you that this is not or has not been a very precise science to date. But we hope that as everyone gains experience in operating these systems in the national airspace more routinely, we'll learn from that. We'll build a base of operational data that can be used to make far better informed decisions on the specific risks associated with the operation.
Okay. So what would make a risk analysis of an unmanned aircraft system be any different from a risk analysis for a manned aircraft system? Why is it different? Karen.
So it's kind of obvious, but it's also, I think, in the end, rather deep. And the biggest difference is we have people on planes, and we don't have people on the unmanned systems. So 2 obvious things that come into play then is the main risk that the unmanned system poses is to the people on the ground, and as we heard this morning in this morning's panel as well, to other aircraft flying around. So we consider that is the biggest problem that we have to worry about. The other part is that the pilot of the UAS doesn't have skin in the game in the same way that the pilot of a manned aircraft has. So we obviously also have many more untrained pilots on the UAS side. So we're dealing with a very different nature of risk for the UASs versus the manned aircraft.
Thank you. Anyone else?
Yeah, George, I think this will be an evolving process. It is different today because essentially the operations that we're seeking approval to do, in the most part, are considered low risk. They're being done over relatively sparsely populated areas, for the most part within visual line of sight, essentially surrounding them with a set of risk mitigations that is pretty robust. There are those who argue, as we get into more congested areas, more complex airspace environments, even to the point where people are on board, that bar for risk assessment will change and be modified appropriate to the particular operation.
Yeah. Well, another thing from a certification perspective is that the ground system is considered part of the aircraft, and as well as the communications link between the ground system and the aircraft itself. So the committee recommends in its report a holistic picture of overall risk and benefit of UAS operations be taken. We're recommending the FAA take that approach. What does that mean? What are some examples?
Well, I think part of that is to look at a balance of the overall risk associated with a particular application. For instance, using a drone. We talk about this in the report about using the drone, for instance, to drop a life preserver to struggling swimmers in the ocean. As an example of there is some minimal risk associated with putting the drone in the air, but the fact that you have, say, one person who is about to drown and then someone else who has to dive in to get them, now you have two people exposed, as opposed to using the drone to take this life preserver and dropping it to assist the one person. So there's an overall level of risk associated with that should be taken into account when evaluating the risk of the drone itself to the how it has elevated the risk in the airspace, and balance that to the betterment, if you will, of society as a whole in terms of the minimizing risk in that regard.
Well, another example in the report, I believe, is that cell tower inspection. There are a certain number of documented injuries and some fatalities of folks inspecting cell towers, a mission that an appropriately equipped drone could do with very little risk to the airspace. So, I guess that's another example. The report recommends that the FAA evolve its risk assessment procedures to being more predictable, more quantitative than qualitative. The report discusses the opinion of the committee, the finding of the committee, that the SMS process, Safety Management System process, as applied to UAS approvals today is rather qualitative. Why does the committee hold the view that it's qualitative as opposed to more quantitative?
Again, speaking from experience, and this is not necessarily the FAA's fault. This is symptomatic of a nascent industry that at this point does not have a lot of empirical data experience behind it to make specific quantitative decisions on risk. As my friend Margaret used to say, we're kind of in a world now where it's rock management. When you bring a new operation to the agency, whether it's part of a certification or part of an operational approval, public or private. You know, it is really based on the amount of homework you do in advance, the risks that you have pre-identified, and bringing them with acceptable mitigations to those risks. And in a lot of cases, you end up talking to a lot of different players within the agency, all well-meaning, all who have heard the talk about, you know, risk-based certification and performance-based certification, as opposed to very prescriptive rulemaking. Unfortunately, it's a hard nut to crack. Again, most of these folks have lived in a very prescriptive world, and you know, and we're not faulting them for that. But as we get into this unmanned aviation spectrum, you know, we're talking about a platform that doesn't have a traditional set of regulations associated with the certification and approval for those operations. So the concept of risk-based, performance-based certification is something that's obviously going to have to evolve over time. As data becomes available, I believe the committee's recommendation is that you know, the FAA takes that to heart and gets more specific in terms of the requirements, and, as opposed to, you know, going in there with all the best intentions in the world and an expectation that you're going to come out with an approval. Well, you may or you may not. So it takes work, it takes effort, and yeah, we'll get there.
Well, in the manned aviation sector, to get a new system in, there are two ways that are internationally approved to do it. The first is you do a target level of safety analysis and all those good fault trees, but it's to a specific target level of safety, a quantitative target level of safety target. The other way is comparative analysis. So if we've got an operation in the airspace to which we can compare the new one, for example, GBAS compared to Category 1 or 2 or 3 instrument landing system approaches, we've got quantitative measures of the performance of the incumbent system. If the new system is safe or safer, as safe as or safer than the incumbent system, fine. But again, there's a quantitative basis for that in terms of the quantitative basis being the performance of the incumbent system. So with regard to drone operations, as of yet, we don't have a specified numeric target level of safety for most drone operations, particularly at low altitude. And again, particularly at lower altitude, we don't have aviation operations to which the UAS operations can be compared to do the comparative analysis. So the committee has recommended, and so it's more qualitative down both prongs with regard to current UAS approvals. The committee recommended that we go to in the interim, some comparative analysis. So if there aren't manned aircraft operations that are comparative, we heard this morning about flying between houses, what would we compare a proposed UAS operation to for comparative analysis?
So I think in going on the example of flying between houses, there's at least two things we can do there. We can compare it to what is currently being done to do the same inspection. Perhaps something that is a little bit easier to think about in terms of risk is something like inspecting power lines. So we can compare to that. And then we can also compare just to ordinary daily activities that are ongoing. So all of us are accepting a certain level of risk in various things that we do. I just went across the street to buy something this afternoon. So across the street. So I'm accepting a risk there. I don't actually even think about it. Well, I do a bit because I think about risk all the time, but most people don't. And so we can compare to these ordinary everyday activities that people are doing and look at what risk does this UAS operation pose, and does it pose an increase above that sort of baseline background risk?
Anybody else?
I was just going to add that the comparative analysis is certainly consistent with the holistic, as a holistic view of looking at risk.
Yep. So the committee recommended a timeline, if you will, for the development of specific guidelines with interim steps for defining de minimis risk, and eventually developing the predictable, more quantitative process where there's more delegation to the applicant of the risk analysis, either to the applicant directly or, if you're at a de minimis risk level, perhaps to the applicant getting insurance. What kind of timelines are realistic, or what's the committee's rationale for the timelines that it recommended?
Well, I mean, I think we're all anxious to get on with it. We've all got interests in advancing this technology and looking to the day where we have routine access to airspace and the opportunity to go off and do real work with these systems. So there is a degree of impatience, I guess, among those of us who are immersed in this industry. That was probably a major driver for what some might think are pretty aggressive timelines in terms of our recommendation. I have reasonable confidence that with continued industry support, again on the data-driven decisions of not only those of us on the industry side, but those in the regulatory side, that these aren't completely unachievable. I think that the 5-10 year outlook that we have in the report is appropriate. I think it's consistent with some of the expectations of others who are working to solve a number of the technical challenges associated with routine airspace access and routine operation within the NAS. This is a global problem as well. Of course, we all know that. These same discussions and same questions are being circulated by others around the world as we all tackle this. But we've got to do as an industry a far better job of getting the information so that we can do this holistic look, that we can do this detailed analysis of the real risks and make informed decisions. That's key.
I would even go back to the 2012 reauthorization where, and I don't think that the timelines that we're talking about are any more aggressive than what Congress had said in the reauthorization bill in 2012.
And right, so there are recommendations with a 6-month timeline to define levels of de minimis risk, 12-month timeline to publish procedures that can be used by applicants to get a more predictable result, in a more transparent across approvals manner. The recommendation to put the new, where risk assessment needs to evolve to is in the 3 to 5 year time frame. But there are also recommendations, because the committee was asked to look at the 5 to 10 year and beyond time frame as well. There are recommendations for research. Karen?
Sure. So I think there's at least 3 main areas in which we need research. And the first one is human-machine interaction. So human and machine interaction has been studied a lot in various fields, but I think now that we have this prospect of fleets of drones operating, the problem becomes a lot harder. So as we think about, for example, an operator who's managing 1 drone is clearly too few. 2 is reasonable. How about 50? How about 100? Where is that cutoff? So we need to understand that part better. So what happens, all the drones are doing their job, they're doing well, and suddenly one of them stops working properly. Now we expect that poor operator to jump in and immediately understand the situation. So this is the basic problem of human supervisory control. Some of you might remember like the episode of The Simpsons as well, with Homer, sort of managing the power station, and he's supposed to be watching everything, and then suddenly something goes wrong. So human-machine interaction, a lot of work is needed there, both in terms of the operator interacting with the drones and other people as well, such as, for example, air traffic controllers. So one great way to get rid of the human-machine interaction problem is just to take the human out completely. So we just have autonomous systems flying around. So that means that now the operator can't make a mistake because they're not there. But how do I know the autonomous system is going to work properly? And right now, we don't know how to guarantee safety for autonomous systems. Autonomous systems can be great because they can react in a more intelligent way than just an automated system that I just send out. So that we have that advantage there. But it does bring with it the disadvantage that we don't know currently how to prove that such a system will behave safely under all circumstances. This is not a trivial problem. This is a really, really hard problem. We've seen a little bit of that with self-driving cars as well. We need to get working on that now. Otherwise, we're going to be behind and we're not going to be able to make use of the powers that autonomy offers us. And then finally, there's sort of a good problem to have, which is, in my research, I often struggle, I don't have enough data. Now, with the prospect of drones and just inherently the age that we're in, we have this prospect of having a lot of data coming in. So there's some policy issues around collecting the data, and the report addresses some of that. And then there's like, what do we do now that we have all this data? Can we have an ongoing live risk assessment picture of what is going on in our entire UAS airspace, for example? So I think that is a really exciting area that has great prospects.
Okay. Questions from the audience then?
Okay, so this question is the risk that was evaluated, or maybe just opinion here, from UAS to people on the ground or to other aircraft in the air, which one is determined to be of a higher concern, and then why?
Well, I can say that in our operations, the primary focus is on the aircraft, and this is my assessment of because there's a component of all of this in the COA process, but the primary effort is on ensuring that the drone doesn't collide with another aircraft. But there is also the concern about, I mentioned that when we start, we would look at the population density of the areas in which we would fly. And so some of the provisions in the COA are associated with, are based on the probability of damaging property or hurting humans on the ground. And in the risk matrix, that is part of what is in there, is the probability of collision, estimating the probability of collision of the drone with a person or with a vehicle. So I would say that in that process, everything is covered, but I think that the emphasis is really on the flying component.
Yeah, the only thing I'd add, I don't think we, as a committee, looked into specific use cases. We look kind of holistically at the process of risk assessment and where the flaws were. We didn't get into the specifics of what is more safe versus something else. That really wasn't our tasking. But while the mic's on, I just want to make one small editorial comment. In spite of what you may read about our report, there was no one on the committee who advocated any kind of compromise to safety. You may interpret some of the things that are said that we're pushing the agency to go faster, and that might imply accepting more risk. I think I can speak for everyone here and the rest of the committee members that those thoughts never crossed our mind. It was always safety first. We want to do the right thing. We just want to make sure we define a process as efficient and well prescribed as it can possibly be. So I just wanted to throw that out before we left.
Okay. George, you have a question that's like dead on to picking up on what Paul just teed up, and that is, what about the goal of taking a lighter regulatory touch on the small, lower risk drones? What does that look like? Again, kind of building on what Paul said, not that you're trying to be unsafe, but anyway, so that'll pick right up on this question.
Okay. Well, we have Part 107, which the committee certainly took into account. And then, so what's the next thing past Part 107? The committee concluded it would be operations with a de minimis risk, and a risk that is assessed as being less than a quantitatively specified de minimis level. For those types of operations, perhaps a commercial underwriting process of insurance gotten by the applicant might serve as the appropriate risk analysis. Depends upon what the de minimis level of risk is. And then beyond that, there would be assessments that could be done by the applicant. As you know, in the 3 to 5 year time frame, there would be a well-prescribed set of options for how to do such a risk analysis, but it would not be done as it is typically today by the FAA, by a SRMP, by a risk management panel. Rather, the effort would be delegated to the applicant using well-defined procedures and reviewed, vetted, and approved by the FAA. Anything else to add to those sort of steps? Oh, and if one is flying a large drone in Class A airspace, in shared airspace with commercial air transport, guess what? Use the standards for manned aircraft operation because that is appropriate to that use case.
You want to have one more question?
Sure.
Okay. All right. This is a real softball. What about culture changes within the FAA to address drones? So, and you only got, like, I think about 4 minutes left.
Right. Okay. The report does talk about moving away from the manned aircraft culture, or evolving that to a culture more appropriate to many of the, or the majority of UAS operations. The culture of looking only at what can go wrong, as opposed to taking a more balanced view of the safety benefits. Our report does not talk about economic benefits of drones. They're huge and they're out there, but that was not our remit. We looked at the safety benefits of UAS operations and thought that they ought to be taken into account, as well as the additional risks of having something else in the airspace. Culture change. Come on, Paul, you cannot remain silent here.
Of course not. No. You know, I think there has been a culture change. I mean, I was part of the original UAS ARC 10 years ago that started looking at integrating small UAS into the national airspace. And I can tell you the kinds of things that were completely off the table, don't bring them up. If you even talk about them, we'll cut your head off. A lot of those things are passé now. Things like night flight, flying an extended visual line of sight, flying beyond line of sight, flying drones that weigh more than 2 kilograms. Things that just, don't even talk about it, are now being enabled. So, yeah, I think there has been a bit of a culture shift. Is there still a ways to go? Heck yeah. But I think we're making progress.
Okay, anyone else on that one? Okay, so in closing, I'd like to thank our panelists, and to add to the accolades that Craig Fuller provided for Margaret at lunch, the very well-deserved accolades, on behalf of the National Academies of Sciences, Engineering, and Medicine, we would like to thank you for being a member of our committee, and thank you for all of the great work you did helping with the generation of this report. Could we thank our panelists, please?